Okay, so what if you could have a personal transcriptionist, someone who types out every single thing you say in real time right there on your own computer? We're talking no cloud, absolutely no delays, and zero privacy concerns. Well, that's not science fiction anymore. That's the promise of a new model called Voxtral Mini 4B, and believe me, it's a huge leap forward in speech-to-text.
You know, this quote from the live demo just nails it. It really gets to the core of what makes this so special. This isn't about uploading an audio file and then waiting around for the text. No, this is a live, flowing stream of words appearing on your screen the instant they leave your mouth. It's a totally new way to think about transcription.
So why are we calling this a game changer? Well, for years, high-quality transcription has been this big trade-off, right? You could get it fast or you could keep it private, but getting both at the same time, that was the real challenge. This model, it just flips that whole equation on its head. Let's break down the old way versus the new way. On the left, you've got your typical cloud AI. Your voice gets sent out over the internet to some server, which of course creates a delay and, let's be honest, opens up all kinds of privacy questions. But on the right, with Voxtral, everything happens right on your device. The result? You get instant text and you get total privacy. Your data never leaves your machine.
Okay, so how in the world does it pull off this incredible speed? The secret is in its architecture. It uses something called a causal encoder. Sounds technical, I know, but let's pop the hood and see what's actually going on. It's pretty cool.
The key word here is causal. Think of it like this. A lot of AI models need to hear your entire sentence. They need to see the future, in a way, before they can figure out the context and transcribe it. A causal system doesn't do that. It just processes the audio as it comes in, piece by piece. It only looks at what's already been said, which is exactly what you need to make real-time streaming possible.
And here's that flow in action. It's actually really simple and elegant. Your voice goes in as a stream of audio, that causal encoder gets to work processing it on the fly, and a stream of text comes right out the other side. There's no buffering, no waiting for you to stop talking. It's just this continuous, seamless conversion of speech into text.
But here's where it gets really, really interesting. You're not just stuck with one setting. Voxtral actually gives you a dial, a way to tune its performance based on what you need at that exact moment.
So, you get to make the call. What's more important to you right now? Is it pure, unadulterated speed, or is it pinpoint accuracy? Maybe you need an instant response for a voice assistant, or maybe you can wait just a fraction of a second longer to get a super accurate transcript of an important meeting. The choice is yours.
On one end, you can crank the delay down to just 240 milliseconds for that lightning-fast, immediate feedback. Or you can stretch it out to 2.4 seconds. Now, why would you do that? Well, giving the model that little extra moment gives it more audio context to work with, which can seriously boost its accuracy.
So, what's the perfect balance? The developers recommend setting it to 480 milliseconds. We're talking less than half a second of delay. At this setting, you get an incredible balance of near-instant transcription while keeping the accuracy unbelievably high. It's really the best of both worlds.
All right, that all sounds great in theory, but how does it actually perform when the rubber meets the road? Let's look at the hard numbers and see how Voxtral really stacks up.
Okay, get this. This is the headline. At that recommended 480 millisecond delay, this real-time model is as accurate as some of the top offline systems. You know, the ones that take their sweet time processing a whole audio file after it's done? To get that level of accuracy, but instantly, that is a huge deal. So looking at the FLIR's benchmark, the offline version of this same exact model has a word error rate of 5.9%. And remember, for error rates, lower is always better. The real-time version, at that 480 millisecond sweet spot, comes in at just 8.72%. That is such a tiny trade-off in accuracy for the massive game-changing benefit of getting your transcription right now. And this chart just makes it super clear. You can see the offline model's error rate in that first bar. And look, the real-time version is just a little bit higher. It's a perfect visual that shows just how incredibly close the performance really is.
Okay, so you're probably thinking, this is awesome, I want to try it, so what do you actually need to get this thing up and running? Let's get into the practical side of things.
First off, the model itself is about 9 gigabytes. You'll run it using the VLLM framework, which is a super popular and efficient tool for this stuff. Now for the hardware. Officially, you'll need a graphics card with at least 16 gigs of VRAM. But it's worth pointing out that the live demo we saw was using closer to 36 gigs, so more is definitely better here. And maybe most importantly, it's released under an Apache 2.0 license, which means you can use it for commercial projects, no problem.
So what can you build with this? I mean, the possibilities are just so exciting. Imagine having completely private meeting transcriptions where sensitive info never ever leaves the room. Or think about live subtitles for events or calls, generated instantly. You could build incredibly responsive voice assistants that don't have that annoying lag. And it does all of this in 13 different languages.
At the end of the day, this technology tears down two of the biggest barriers we've had in transcription: delay and privacy. So the real question isn't just about what we can build with it today, it's about what happens next. With tools this fast, this private, and this accessible, what new conversations and big ideas are we going to unlock tomorrow?